Hey guys, welcome to Stat 441 at Virginia Commonwealth University. This is part 2 of the lecture for binomial random variable. Here are a couple of examples using the binomial random variable. So the first example here, we need to find the mean and variance and standard deviation for a binomial random variable where n is 20 and p is 0.6. And we also want to construct the interval mu plus minus 2 sigma and compute the probability within that interval. So since this is a binomial distribution and n is 20, that means there are 20 independent Bernoulli trials. And for each trial, the probability of success is 0.6. So that's n 20 and p equals 0.6. The mean and variance of a binomial random variable are given by these formulas, mu equals np. We've shown this in the previous video. So the mean is 20 times 0.6 or 12. And the variance is n times p times q, which is 20 times 0.6 times 0.4. Q is simply 1 minus p. So the sigma squared is 4.8. The standard deviation will be the square root of 4.8, which is 2.19. Mean is 12. Standard deviation is 2.19. Now using these values, we can create the interval mu plus and minus 2 sigma. So 12 plus and minus 2.19, which gives our approximate interval to be 7.6 through 16.4. To compute the probability within this interval, we will have the probabilities at 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay, so within the interval, there is, since it's a discrete variable, we don't have probabilities for the fractional values. We only have probabilities at the discrete values. So these can be calculated using the probability formula for the binomial distribution. So this will be a few calculations, but when you calculate all of these probabilities and add them up, it gives you 0.963. Okay, so within 2 standard deviations, approximately 0.963 of the distribution. So that is the mean and variance of a binomial random variable. Now this is what the distribution would look like if we had calculated all the probabilities. So for this example, since n is 20, the values of our random variable will start at 0 and go all the way up to 20. And for each individual probability, we calculated the probability at 0, 1, 2, so on and so forth. This is what the distribution would look like. It's actually pretty close to a normal distribution. Here's another example of the binomial experiment or binomial distribution. An issue of Consumer Reports found widespread contamination and mislabeling of seafood in supermarkets in New York City and Chicago. The study revealed an alarming statistic. 40% of the swordfish pieces available for sale had a level of mercury above the FDA maximum amount. For a random sample of 3 swordfishes, find the probability that all 3 swordfish pieces have mercury levels above the FDA maximum. Exactly 1 swordfish piece has mercury level above the FDA maximum limit, and at least 1 swordfish has maximum mercury level. Now, how is this an example of a binomial distribution? So we are picking 3 in the sample. So these are our 3 independent Bernoulli trials, and each individual trial has a probability of 40% of being above the maximum amount or maximum limit. So P is 0.4. Probability of success in this case is 0.4. And our probability or our success is defined as that the level of mercury is above the maximum amount. The probability of failure is 0.6. So in the first example here, in the first part here, we need to figure out the probability that all 3 pieces have mercury levels above the FDA maximum. So we can use the formula directly here for finding the probability of y equals 3. We have 3 choose 3, okay, which is 3 factorial divided by 3 factorial times 0 factorial. Remember, 0 factorial is always 1. Okay, so this basically is 1.4q probability of success, and this is y, 0.6 times n minus y. So in this case, it's 0. So 0.064 is the probability. And even with based on the example that we have seen before, the probability that all three are successes, there is only one combination that you have all three successes. That's why our 3 choose 3 in this case is 1. Okay, then we can find the probability exactly 1 has contamination or above the FDA limit. This time it's 3 choose 1, 0.4 raised to y, and 0.6 raised to n minus y. So 0.4 squared and 0.6 raised to 1. 3 choose 1 is 3 factorial divided by 1 factorial times 2 factorial. Okay, that gives us 3. So 0.432 is the probability that y is exactly 1. The third part is probability that y is less than equal to 1. So 0 fishes could have contamination or just 1 fish. So we have to figure out both probabilities and then add them up. So this is 3 choose 0, 0.4 raised to 0, 0.6 q, and for 1 we've already seen it here, so it's the same one. 3 choose 1, 0.4 square times 0.6 raised to 1. So this gives us 0.216, this gives us 0.432, and the total is 0.648. So this was an example of the binomial experiment. Please watch the next video for another distribution, which is the Poisson distribution. Thanks for watching.